So in this type of question, your understanding of primary alcohols and how they're oxidized is tested. So you need to know that primary alcohols can be oxidized up to aldehydes, and the aldehydes can be then oxidized up to carboxylic acids. Over here we have two different bits of apparatus you need to recognize. One is a distillation. So in that you have ethanol and acidified potassium dichromate and distillate. So the reaction happens in there. Something boils up, it's distilled, hits the condenser, condenses and drips down. Over here we have heating under reflux. So you form something, you react up there, it goes, it hits the condenser and it comes back down. So any product you make in this reaction goes up and comes back down and reacts again. Over here you can make something and then it can distill off and be collected and won't react any further. So the question says the ethanol can be oxidized to form either ethanal, CH3CHO, or ethanoic acid, CH3COOH. The boiling points of ethanol, ethanal and ethanoic acid are given in the table below. So ethanol, the alcohol, is 78 degrees C. Ethanal, CH3CHO, is 21. And ethanoic acid is CH3CO2H, is 118 degrees C. It says use this table, that's the key point, use the table of boiling points to explain why the organic product is likely to be ethanal if the apparatus in figure 1 is shown, and why the organic product is likely to be ethanoic acid if the apparatus in figure 2 is shown. So I think what happens is, when you heat ethanol, the alcohol, with potassium dichromate, the first thing that happens is it gets oxidized up. I'll show it with the square brackets O, which shows that's an oxidizing agent. That represents the potassium dichromate. The first thing that happens is the ethanol gets oxidized to ethanal over here. So the ethanol, the alcohol, makes ethanal, but the ethanol only boils at 21 degrees. The water baths at 60. So that means the second you make ethanal, the aldehyde, it boils, condenses and drops back down. So the ethanal collects there before anything else can happen to it. So the correct answer for this would be the most volatile compounds can escape. Most volatile compounds escape. Therefore, the ethanal, capital AL, just so you can see easier, boils before it is fully oxidized. So the ethanal escapes before it can be oxidized any further to the ethanoic acid. But in figure 2 what happens? Well, in figure 2 exactly the same thing. The ethanol is oxidized to ethanal. But the ethanol can't escape. It can't go up the top because as soon as it gets to about there, it condenses back down. So it goes further. In figure 2, it gets oxidized again. So the answer to this is volatile compounds cannot escape. And because they can't escape, there is full oxidation. Therefore, full or complete oxidation.